morning, class. It's Sir Capistana again, and welcome back to our Physics 1. Uh, for today, we'll be talking about work and energy. So, by work and energy, isipin nyo, Sir, work, di ba para, sir, parang force lang din ito? Parang pinag-uusapan lang din natin yung application, newtons, ganyan-ganyan. So, suppose, ganito. Uh, Halimbawa dati, naglalaro ka ng tinatawag nating slingshot or yung tinatawag nating tirador. So, by using that tirador, pwede ka actually mag-compute ng speed ng magiging trajectory ng iyong binala sa iyong tirador. Pero, no matter how hard you attempt or replicate lahat ng actions or yung paghila mo dun sa tirador, nagbabago-bago pa rin yung direksyon. Just like our project last time wherein I asked you to create a ramp, tapos dun sa ramp, magpapagulong ka ng bola, tapos yung bola, uh, pinakalculate ko sa inyo kung gaano kalayo ba dapat, yung horizontal distance or yung horizontal range nung cup na sasalo ng bola nyo. And even if sobrang na-compute niyo na or sobrang eksakto na ng computations niyo, there are times na sumasala pa rin yung laglag ng bola dun sa ating cup. So, basically, hindi natin kayang i-quantify lang lahat ng bagay using what we call Newton's law. We should account for different mechanisms or different factors that may affect the movement of our objects. And in that, we will be actually looking into this part of physics called work and kinetic energy. So, kasi bale yung Newton's law natin, basically that is the most simplest way on how we can calculate the speed, the velocity, and the acceleration of objects or particle in motion. But in some cases, uh, we may encounter the principle of conservation of energy, wherein in that principle of conservation of energy, there are some moments na mas mataas yung nagiging kinetic energy or potential energy ng mga objects natin. Therefore, nagbabago-bago yung results ng actions natin. So, in that, suppose let's define our work. And by work, it is actually the change in kinetic energy caused by forces acting on an object. So, basically, dun sa project nyo minsan, there are some external forces bukod dun sa let go nyo dun sa bola na nag-a-act dun sa ping pong ball. So, basically, dito na papasok yung work natin or what we call the change in kinetic energy caused by forces acting on it. So, kung ipapadefine ko sa inyong work, basically, kung isipin nyo, ang work is anything or any activity that requires muscular or mental effort. But in physics, when we talk of work, it is more on making use of relating the motion of objects to kinetic energy, where in kinetic energy is actually a quantity that is related to the particle speed. So basically, having certain mass or constant mass, kapag nagbabago-bago yung speed ng object, magbabago-bago rin yung kinetic energy. And that pagbago-bago ng kinetic energy is what we call force, or work, rather. So, by work, uh, we can actually define work on the basis of force. So, sabi niya kasi, it is the tendency or yung change ng movement of object or change ng kinetic energy ng isang object. So basically, if we talk of work, kung halimbawa meron kang isang object, let's say meron kang box, yung box na yan ay naglalay sa isang surface. So connect lang natin yung ano. Uh, if you if a force is exerted on that box, this box may actually move from a certain direction. Let's call this movement or displacement as S. Okay? Wherein magmo-move yung box natin for that initial position towards this final position. That is due to our application of our force. So basically, that is our work. We're in work, that this is capital W. Don't be mistaken this as our weight. Okay? So work is actually just a product of our vector force and yung ating displacement na S. So, bakit S yung ginamit? Hindi ko rin sure kung bakit S yung ginagamit na conventions dito sa pinag-uusapan natin uh, work. So, basically, that is our work. We're in work, eh, uh, work done on an object due to a certain constant force uh, is equal to this. Wherein we have here work is equal to force times the displacement. Or ito yung tinatawag nating, pwede natin din song isulat as work is equal to force times that displacement, which we call the constant force in direction of straight line displacement. So basically, if we have this, kung i-consider natin yung ating diagram dito, or yung ating illustration dito, if we are to compute for the work done on an object para mag-move siya from this position, itong starting ng S towards dito sa dulo ng S, ang kailangan lang natin gawin ay alamin kung ano yung distance ng S na yan at how much force is actually exerted on our object. So basically, if our force here, say, our force here is just 10 newtons, and yung distance na na-cover natin is, let's say, 5 meters. So, we will have here work that is actually equal to 10 newtons times 5 meters. So basically, the work done on this object is just 50 newton meter. So that is our work, or the definition of work. So basically, if we look into work, ma-encounter natin yung tinatawag nating joule. Wherein joule is actually the SI, or the International Systems of Unit, or SI unit of work. Okay? Wherein actually joule, it is joule, is actually equal to 1 joule is just equal to 1 newton multiplied to 1 meter. So, yan po ang ating joule. And we can actually write this as 1 J, J for joules, and 1 for N, Newton. Okay? So, this is also equivalent to kung gagamitin natin yung British system, 1 joule is actually equal to 0.7376 feet per pound force. Okay? So, and kung kukunin natin yung 1 joule or yung 1 feet per feet found of force, that will be 1 feet pound of force is actually equal to 1.356 joule. Okay? Para lang alam natin yung units natin. Okay? So, That is the definition of our work and its SI unit. So, move on tayo doon sa ating mga computations when it comes to work. So basically, halimbawa, doon sa ating straight line displacement, meron tayong mga cases na hindi laging nasa direction nung ating movement yung or nasa direction ng displacement yung work. There are some cases na pwedeng yung push mo or yung application ng force ay hindi aligned dun sa ano natin, dun sa displacement natin. So kanina, yung pinakita ko sa inyo, yung displacement natin, kung gagawa natin siya ng diagram, yung ano natin, yung displacement natin ay in the same direction ng ating force. Okay? So, pasensya nyo lang, hindi ko mantay. But there are some cases na pwedeng magkaroon tayo na nakaanggulo yung ating forces in comparison with our displacement. So in those cases, paano natin i-compute yun? So halimbawa, ganito ano, yung displacement natin ay paganyan. Okay, so it is going to the right. That is our displacement. So, paano kung may cases tayo na yung force natin, ang push natin or yung pull natin dun sa object ay paganyan? Meron tayong certain theta dito or certain angle na nag-e-exist dun sa or na difference dun sa direction ng ating force at ng ating straight line displacement. So, paano natin gagawin yan? So, actually, a-apply lang natin yung ginagamit na natin dati sa vectors natin wherein we will just use our trigonometric functions. And since we are just dealing with a straight line, we can assume that the straight line displacement, yung S natin, is always moving at the x direction. So, since it is moving in the x direction, we can just write our straight line displacement of work. We can just define our work as just the force applied on an object, okay, multiplied to our straight line displacement, multiplied to cosine of our theta. Okay? So that is our straight line displacement. So kumbaga, may cases tayo na meron tayong halimbawa, yung angle natin, yung theta na yan ay equal sa 45 degrees. Okay? Then, ang force natin, gamitin lang din natin yung force na ginamit natin kanina, na 10 meters, 10 newtons. Then, our displacement is 5 meters. So, how do we compute this? So, basically, for the work of this one, mangyayari lang, we have their work is equal to the force, which is 10 newtons, and we just need to multiply that to our 5 meters, and multiply that to the cosine of our theta, and for the scenario, our cosine is 45, our theta is 45, so we have here cosine 45. Okay? So, ganun pa rin naman yung computation. So, we'll have here 50 Newton meter. Ang cosine 45 is just 1 half or 0.5. Meaning to say, our work here is 25 newtons meter. Okay? So, that is our straight line displacement. So, we just need to account our straight line displacement or yung S natin as nasa x-axis. So, magkakaroon tayo ng cosine dito. Okay. So, ang tanong dito, class, is work scalar or vector? Sige nga, hula nga kayo. Pause nyo muna yung video. Pag-isipan nyo muna. Okay. So, our work is actually a scalar property. So by scalar property, even though it is calculated using our vector quantities, wherein gumagamit tayo ng force at displacement, parehas silang tawag dito, parehas silang vectors, magiging scalar pa rin yung work natin. Kasi kung imagine nyo, halimbawa na lang, you have 5 Newton force towards east. Sabihin natin 10 meters papuntang east. Okay? Wherein yung force natin ay papunta rin east. Tapos meron tayong 5 Newton force equal yung magnitude ng forces natin na papuntang north. Tapos papunta siyang 10 meters north. So, kung titingnan natin dito, class, kung i-compare natin yung directions ng ating yung ating mga work dito na done on a certain object, let's say, if we are to compute for the work dun sa east, since same direction yung movement ng force natin at nung ating straight line displacement, ang mangyayari lang dyan, magkakaroon tayo dyan ng 5 newtons, imumultiply lang natin sa 10 meters, which is actually 50 newton meters. Okay? So that is work done towards the east. How about the work towards north? Okay? So kung titingnan natin, ganun lang din Magkakaroon tayo dyan ng 5 newtons, multiply lang din natin sa 10 meters. So we will have here 50 newton meters. As you can see here, both of those directions na parehas yung direction nung ating straight line displacement and yung ating direction ng force, naging parehas lang din sila na 50 newtons meter. So basically, in that, uh, magkakaroon lang din tayo ng same amount of work done on a certain object as long as the force is actually moving the same direction with our straight line displacement. So basically, our work is actually scalar. So in that, remember na lang class na ang ating work ay scalar. Okay? So, let's have here a sample problem wherein we are to calculate the work done by a constant force. So, ito ay isang example lang, napapakita lang natin yung definition natin or yung ating pinakita kanina na ang work is just actually equal to our uh, force multiplied to the direction of our straight line displacement. So, himay-himayin lang natin yung problem. So, we have here, imagine pushing a stalled car with a steady force of magnitude 210 newtons for a distance of 18 meters. Due to how human anatomy work, the direction of your push was not straight and is angled at 30 degrees. How much work was done on the car? So, ano yan? So, himay-himayin lang natin. So, meron tayo dyang applied force or directional force which is actually 210 newtons. Okay? With a degree of, we have here a theta which is actually 30 degrees. Okay? Then, we have here straight line displacement which is actually 18 meters. So in here, pwede na natin gamitin class yung pinag-usapan natin kanina. So we are to compute for the work. So work here will be just equal to our directional force, our straight line displacement multiplied to our uh, cosine theta. Okay? So paano kasi yung nangyayari dyan para lang ma-visualize natin? So kung itong dot na to ay nagre-represent dun sa R, we have here a straight line displacement which is actually equal to 18 meters. As meron kang push meron kang push na equal sa 210 newtons na naka-angle ng 30 degrees. So, ganyan yung itsura ng ano natin, ng ating free body diagram dyan. So, basically, we will have here 210 newtons. Then, we just need to multiply that to our 18 meters. And you just need to multiply that to your cosine of 30 degrees. Cosine of 30 degrees is somewhere about 0.83. And we have here 210 times 218. So we will have here, we will have here 1,800. Let me just compute. So let me just get the calculator. So for that, we have here 210 multiplied to 18 multiplied to cosine yan. Wait lang. Baliktarin natin class ng computation ha. So, pwede naman. Pakita ko sa'yo. 210 times 18 times 30 then cosine. So, hmm. Ganito. Tama. Okay. So, we will have here, let me just erase this. We will have, uh, ano na ba yun? 3,273 joules. Pero since class 2 lang yung significant digits natin, kailangan natin itong i-convert. So this will be 3,300 joules, or we can simply write this as 3.3 times 10 raised to 3 joules. Okay? So that is the amount of work that is done on the on pushing that stalled car o yung nasira ang sasakyan niya. Okay? So those are our work done by a constant force on a straight line displacement. Okay? So let's go deeper into this. So, bali class, yung mga pinakita ko sa inyo, yun actually ay ideal ano lang, ideal work or ideal situation when it comes to work or on the direction of force. So there are some cases that we may encounter some force that are actually have different directions in comparison to the direction of the straight line displacement. So, bale, ang gagawin natin class, pakita ko na lang yung mga pwedeng mga scenario. So, drawing muna ako. Meron kang box, meron kang straight line displacement, tapos, nag-move yung box, syempre. So, gawin natin tong imaginary. So, pwede kasing yung force natin ay ganyan. So, we have here directional force. And in some scenarios, pwede tayo magkaroon ng straight line displacement na ganito. Sa kanan, andito yung original na position ng box natin. Pero anong nangyari, imbis na pa-forward yung push mo or yung pull mo, andito yung ating direction ng force natin. Pero since nag-move pa rin siya dyan, sige, tingnan natin kung ano yung mangyayari dito. And we also have scenarios na nagmo-move yung object natin in a certain straight line displacement. And halimbawa yung force natin is moving upward. So ano kaya yung mga values ng work natin dito? So, kung makikita natin dito, dun sa unang ano natin, uh, our force is actually on the direction. Yung force natin is actually, the direction of our force for our first scenario is actually moving towards our straight line displacement. So for our second scenario, our force is actually moving away from the straight line displacement. And for the third scenario, makikita naman natin yung force natin ay, kung titingnan natin, actually ay perpendicular. So, dito, kung i-consider natin class yung ating straight line displacement, pwede actually tayong mag-draw ng imaginary line dun sa ating straight line displacement na perpendicular dun sa ating straight line displacement. Ibig sabihin, pag perpendicular, that will form a 90-degree angle dun sa ating straight line displacement. So, in this scenario, kapag ang gagawin natin dito ay gagamitin natin yung formulas natin for our straight line displacement, makikita niyo actually yung force dito, kapag ang force natin ay or yung direction ng force natin or the theta of the force is actually in between siya ng 90, sabihin natin, less than 90. So, kapag less than 90 yung ano natin, yung direction ng force natin, our work here will actually be positive. Okay? And for this one, wherein the theta of the force is actually between 90 and between yan, hindi equal sa 90 and 180 degrees. Okay? Our work is actually negative. Okay? So, saan ba yung 180? Yung 90 natin ay yung nandito sa taas. And yung 180 natin ay yung nandito sa kabila ng ating S. Okay? So, kapag meron kang ganyang angle with your straight line displacement, your work is actually between, yung between dito. Your work here is actually negative. Okay? Hanggang equal yata yan dun sa 180. Okay. So, for this one, kung makikita nyo, perpendicular, ano? So, the theta of our force is actually equal to 90 degrees with respect to our straight line displacement or yung S natin. So, for this one, our work here is actually 0. Sir? Parang gano'n magtataka kayo. So, parang lumalabas pala, ano? Kapag ikaw ay nagbubuhat ng bagay, tapos bit-bit mo siya na hindi siya nagmo-move up and down, pero yung force mo ay upward, ibig sabihin you're actually exerting zero work on the object. Okay? So, the work is actually applied on different parts of your body. So, that is what we call our zero work. So, by zero work, there are actually scenarios when force is perpendicular to the straight line dispersion or displacement. It just means that our work is zero. Okay? So, let's just clarify that. Okay. So, that is actually represented by different scenarios wherein, halimbawa, nag-hold ka ng isang item at a certain position kasi hindi mo siya ginagalaw, hawak mo lang siya. So, halimbawa, carton yung kamay mo, tapos may hawak ka ritong apple, tapos hindi mo ginagalaw yung apple na yan, nandyan lang yan sa pwestong yan, hawak mo lang siya, ibig sabihin, you're actually exerting zero work dun sa iyong apple. Pero kapag ibinaba mo na siya, or may direction ka ng pababa, ibig sabihin, kakaroon ka ng S that is moving downwards, and yung force mo ay since moving downwards din siya or upwards din siya, saka lang siya magkaka-work. Okay? Pero kung halimbawa, hawak mo siya ng ganyan at ikaw ay nagmo-move, so, syempre, yung force mo ay upward, tama ba? Tapos ikaw, sabihin na natin, ikaw ay nagmo-move across the hall, hinilakad mo yung apple na yan. Kung makapapansin nyo, our theta here is actually equal to 90 degrees. Ibig sabihin lang yan, ang work natin dyan ay 0 joules. Okay? Just like this example. So imagine holding or lifting the box, how much work was done on the box. If binubuhat nyo pa lang siya pataas, there will be actually a positive work done on that object. Pero kapag hinold nyo na lang siya, as in nasa isang position lang siya, hindi nyo siya binababa, hindi nyo siya inaangat, you are actually exerting zero work on that object. Okay, so hopefully matandaan yan ha. Okay, so that is our positive, negative, and zero work. Okay, so in that, alam naman natin sa physics, hindi naman nag-work na iisa lang yung force na apply dun sa isang object. We will actually have some cases na we will have several forces acting on an object. So for this example, halimbawa, dito sa isang box na to, nung nandyan sa kanan, we actually have there a box sitting on a surface. So that box sitting on a surface actually has a straight line displacement towards the right. So makikita natin dito, meron siyang pull. Siguro ito ay tension force. So we have here a force that is actually tension. And as you may have remembered, dun sa mga application ng Newton force natin, we actually have different other forces acting on this object. First things first, we have here our weight. Okay, so that is a small w. Okay, tapos we will have here our normal force. And syempre, hindi mawawala yung effect ng surface natin. So meaning to say, we will have here our friction force. So those are our different forces acting on the object. So paano yung work dito? So paano natin i-apply yung understanding natin ng work if we have several forces acting on an object. So basically, we just need to get the summary of the work of each forces. So para ma-compute natin yung ating work sa buong system. So or pwede nating i-apply yung ating mga yung understanding natin ng vectors to actually calculate for this one. So pwede mong gamitin 'yon wherein pwede mong gamitin yung component component forces, okay? Para magawa mo yan. So kukunin mo lahat ng x components ng ng forces mo, kukunin mo rin lahat ng y components mo. Tapos pero since ang movement lang natin ay straight line or on the surface, hindi na natin gagamitin yung ating mga y components. Okay? So, yung total mo dyan, you just need, after you calculate the total or the summation of all your forces, you just need to multiply that to your straight line displacement, makukuha mo na siya. So, pakita lang natin yan. So, halimbawa, meron tayong magkaibang forces na nag-a-act dito sa box na to. So, let's say, itong box na to ay mabigat. So, let's say this box weighs 14,700 newtons. Okay? Then, we have here a pull. Meron tayo ditong hila, which is actually 5,000 newtons. Tapos sabihin na natin yung friction force natin ay medyo mataas din. We have here a friction force which is actually uh, 350 newtons. So, paano na natin kukompute yan? Or paano natin gagawin yung computation nito? Let's say our straight line displacement is equal to 20 meters. So, paano natin gagawin yan? So, first na pwede natin gawin, we just need to get the summation of all the work done in the system. Itong ano muna, first na equation dito. So, ang pwede natin gawin dyan, since alam natin ito ay flat surface, or tapos meron tayong weight na 14, tapos meron tayong normal force na 14,700 din yan. Diba? So, based on our understanding. So, for the free body diagram of that, for the calculation itself, our work total will be just the work ng weight natin, okay? Which is itong 14,700 newtons. Multiply lang natin dun sa movement nung sa ating S, at since ito ay perpendicular, ito ay magiging 0. Okay? Then we also have here our normal force. We just need to add that normal force. And as you may see here, our normal force is actually perpendicular to our movement of our straight line displacement. Meaning to say, this is actually also 0. Then we have here the work of our friction. Work of our friction will be just 3,500. And since this is moving on the opposite direction, we will have here negative 3,500 newtons multiplied to 20. Okay? Then you just need to add your tension force, tension work, since on the same direction sa nung ating straight line displacement, we'll have here 5,000 newtons, hindi siya negative. Multiply lang natin siya sa 20 meters. Siyempre, huwag niyong kakalimutan yung cosine. Let's say ito ay 39.1 degrees. Ano, let's say, ano na lang, ng malapit sa 40. 36.9. Okay, so 36.9 cosine of 36.9. Okay? So, computations na lang. So, balik lang natin yung calculate natin kanina. So, what we need to do here is, since 0 naman na yung dalawa, hindi na natin sila i-add. So, we just have their so, let's have here our 3,500. That should be negative. Let's multiply that to 20 meters. Okay? Then, we will add that to 5,000 newtons multiplied by 20 multiplied by 36.9 cosine. Okay? So, we will have here, we will have here 9,968 joules. Okay? Or, we can, since lowest na natin ay lowest significant digit natin ay 1, kasi 5,000 hindi counted yung trailing zero kasi wala siyang decimal point, we can just write this as 10 kilojoules. Or by 10 kilojoules, this is actually 1.0 times 10 raised to 4 joules. So, yan yung mga ways ng paano nyo isulat yan. So, para naman dun sa isang way, ang gagawin lang natin dun, para dito sa method number 2, you just need to get the summation of all your Fx and summation of all your Fy. Okay, so for the Fy, andyan yung ano natin, yung tension force, yung normal force, at saka yung sulat muna natin to. Sulat, andyan yung ating tension force. Okay? Then, andyan yung ating normal force at saka yung ating weight. Okay? But since our movement is towards the right, hindi na natin kailangan gamitin to. Kung upward sana yung ano natin, yung displacement natin, gagamitin natin siya. Pero for this one, X lang kasi yung movement ng direction natin. So, yung work lang ng X yung kailangan natin. So, in here, kailangan natin yung FT. So, we will have here 5,000 newtons. Since angled siya, you just need to multiply that to cosine 36.9. Then, you need to add your friction force kasi yun lang naman yung kasama dito, which is 3,500 newtons. Okay? So, if you calculate this, natin. So, we will have here 5,000 newtons multiplied to 36.9 or cosine of 36.9. Then, we need to add, not add, subtract 3,500. So, we will have here 498, or let's just say that that is equal to 500. Okay? So, that is the summation of our FXs. So, for the work total, you just need to get that summation. So, you have there 500 newtons. You just need to multiply that to your S, or straight line displacement, which is 20 meters. So basically, you will have here 10 thousand joules, or which is just 10 kilojoules, or just 1.0 times 10 raised to 4 joules. Okay? So that is how we calculate for the total work of our of a system, wherein a system has different forces or several forces acting on it. Okay? Medyo halfway na tayo class dun sa discussion. So, hopefully, andyan pa rin kayo at nanonood pa rin. So, kung marunod pa rin kayo or nagpipay attention kayo dito, chat lang sa akin ang word na na bazinga. Sobrang G. Para sa 2 points na bonus sa next na quiz. Okay? And in that, we'll be moving into kinetic energy and the work energy theorem. So, as kinetic energy, when we talk about kinetic energy is actually associated with our speed, or the speed of the objects. So, by the speed of the objects, uh, we can actually look into the use of Newton's laws and some of our constant acceleration formulas to actually calculate for the force. Kung makikita natin dito, meron tayong isang object that moves from a position to a final position, and that move from initial position to final position is actually a straight line displacement. So in that, you can actually relate force and our kinematics, yung ating ginamit ng mga equations dati, to actually calculate or define our kinetic energy. So as you may have remembered, based on Newton's law, our force is actually equal to mass times our acceleration in x. As you can see here, we have mass here, a constant mass of an object. And we can actually also calculate for the acceleration of this certain object. In that note, we can actually use this formula wherein, as you may have remembered, we can use the final velocity or V2. So V2 ay yung speed dito sa second na yan. V2 squared is actually equal to V1 squared plus our acceleration, 2 times acceleration times, kung maalala nyo, ito ay yung ating delta x. But for this scenario, we will be using our straight line displacement. So in here, pwede mo actually makuha yung ating acceleration part in x. So by that, using algebraic computations, we will have here our acceleration is actually equal to our v2 squared minus our v1 squared over 2s, wherein s is our straight line displacement. And in here, pwede mo nang i-substitute yung value ng acceleration na yan towards dito uh, sa ating definition ng force. Wherein, pwede mong isulat na ang force natin ay equal sa mass times acceleration in x, which is actually equal to our uh, mass times v2 squared minus v1 squared all over 2s. And by some manipulation, pwede mo actually isama yung S na yan dun sa F natin. Wherein we will have here Fs is actually equal to 2 na lang may iwan dito sa baba. So we have here 2. Then we will have here 1 half. Then we will have here M times yung ating V2 squared and yung ating V1 squared. Okay? And pwede mo actually yung simplify wherein magkakaroon ka ng 1 half M B squared ng 2 minus 1 half MB B1 squared. And kung mapapansin nyo dyan, may something dito sa formula na to. Ano nga ba ulit ang Fs? As you may have remembered, Fs is actually work. And that in that case, we have here a change of kinetic energy. Kaya mapapansin nyo, pwede na natin actually i-define dito yung ating kinetic energy, wherein our kinetic energy is actually equal to 1 half mass times velocity squared or speed squared. So this is actually the definition of kinetic energy. So saan ko nakuha yan? So dito siya ano. So as you may have remembered, since ang Fs natin ay actually equal sa work, and as you may see here, we have here changes. Nagpalit ng yung from final position and initial position, there is actually a change in kinetic energy. Meaning to say, that each part of that formula, yung ating 1 half times mass times the velocity, the square of the velocity of the final position, and 1 half mass times velocity squared of the initial position are actually the quantities or the quantities of our kinetic energy. So that is the definition of our kinetic energy. And in here, let me just illustrate the changes that may na pwedeng mangyari depending on the uh, depende rin sa mga bodies natin. So as you can see here, we have here two bodies. They have, kung makakita nyo, parehas sila ng size, meaning to say, or kung parehas sila ng parehas sila ng mass. Okay? Parehas din sila ng, let's say, ng velocity. Magkaiba lang yung direction. But, kung iisipin nyo, using our definition of kinetic energy, wherein kinetic energy is equal to 1/2 times the mass times the square of the velocity. The kinetic energy of these two are actually equal. So, okay. How about this two? Kung mapapansin natin, we have here a mass, right? And we have here, say, twice yung mass nito. And similar yung velocity nila. So, ano mangyayari? For this one, yung kinetic energy nito ay actually twice nung kinetic energy nito. Okay? So, this one has twice the mass, same velocity, which is actually equal to twice kinetic energy. Okay? So, how about this one? So, as you can see here, we have here similar masses, and then we have here velocity, and we have here twice the velocity. So for this one, since they have the same mass, twice the velocity, ano kaya yung magiging kinetic energy niya? So kung i-apply natin to, since naging twice yung energy, magiging 4 times 4 yung nandito. So we will have here 4 times kinetic energy. Okay? So those are the different kinetic energy of different bodies, depending on their sizes, depending on the direction of the velocity. Kung similar yung component ng mass at similar yung components or yung magnitude ng velocity, equal lang yung magiging kinetic energy ng ating mga masses. That is for the first scenario. If we have similar velocity for different bodies, pero yung isa ay mas mataas yung mass, we will have here twice the kinetic energy or more kinetic energy. So, kumbaga, kung iisipin nyo, kung magsing bilis yung kotse at yung isang loader or yung isang truck, uh, mas mataas yung kinetic energy doon sa truck kaysa doon sa ano, doon sa kotse. So, kung dito naman sa last scenario, doon sa third na pinakita natin, kung pareha sila ng mass, pero mas mabilis tumakbo yung isa, uh, it will have higher kinetic energy. Okay? And kapag nagdoble, actually yung halimbawa, yung isa tumatakbo lang siya at a speed of 2 meters per second, tapos yung isa tumatakbo at 4 meters per second, 4 times yung kinetic energy ng isang yun kesa dun sa 2 meters per second. Okay? So hopefully, malinaw yung comparisons na ito. Okay? So in that, going back to the definition of work, since we say that work is the change in kinetic energy, we can actually just rewrite work as parang ganito. So basically, all total work will be just the difference between the final kinetic energy minus the initial kinetic energy. Okay? So basically, kapag nanggaling ka ng zero, or zero kinetic energy, tapos nag-jump ka into 1,000 kilojoules yung sa K2 mo, ibig sabihin yung total work mo dun ay uh, 10,000. Ilan ba yung sinabi ko? Kung ilan mo yung sinabi ko. So, this is what we call the work energy theorem. Okay? So, uh, so in that, kapag hindi gumalaw yung object, pag hindi nag-change yung kinetic energy ng isang object, meaning to say, wala tayong makakalculate na work. So, halimbawa, nag-retain ng certain speed ng isang object. Wow, from 2 meters per second at first yun sa initial position, tapos 2 meters per second pa rin siya dun sa next na position. Ganun pa rin yung kinetic energy. Ibig sabihin, walang nadagdag na work dun sa moving object. Or, kumbaga, pwede rin nating sabihin, the object is at rest. Meaning to say, it has initial kinetic energy of zero. Kapag hindi siya gumalaw, zero pa rin yung kanyang kinetic energy. Meaning to say, there's no work done in that system. So, basically, when we talk about kinetic energy, pwede na rin natin i-define siya. Nasasabihin natin na uh, the total kinetic energy or yung work na sinasabi natin, uh, kinetic energy is the amount of work that needs to be done on a certain object to move it from to a certain velocity from rest. Pwedeng ganun. Pwede rin nating sabihin na yung kinetic energy natin, depending dun sa inertial frame na tinatawag natin, kapag pag hindi ka from rest, sabihin natin, kinetic energy is the amount of work that needs to be done on a certain object to slow it down or make it faster. So, yun yung ating kinetic energy. In that, we can actually use work and energy to calculate speed. So, for example, here we have here. Suppose you applied force to a box that weighs 470 newtons that has an initial speed of 2 meters per second. A total work of 1,000 joules was done on the box. Ang gusto niyang malaman is what is this bakit sled yan? That should be a box. May iniisip ko kanina. Speed of the box after it moves 20 meters. Okay. So, meron tayong ilang force lang na binigay sa atin. So, sabi niya meron tayong applied force. Yung applied force natin ay 1,000. Ay, hindi pala force yun. Joules yun. Meron tayong total work which is actually 1,000 joules. Kasi yun yung sabi niya. A total work of 1,000 joules. Tapos may initial speed tayo. Ibig sabihin, ang V1 natin dito ay 2.0 meters per second. Then, meron tayong force na weight, which is actually 14,700 newtons. Meron tayong straight line displacement, which is actually 20 meters. Ang gusto niyang makuha ay yung speed after it moves 20 meters. Ibig sabihin, we are missing our V2. So, paano natin i-compute yun? So, may ilang mga concept tayo or mga ilang computations tayong pwedeng gamitin dito. So, pwede nating gamitin yung ating work energy theorem, which is total energy is equal to our K2 minus our K1. Okay? Also, since meron tayong weight dito, pwede natin gamitin yung ating force due to acceleration of gravity para makompute yung mass natin. Kung maaalala nyo, ang weight natin ay actually equal to our mass times gravity. So, we can transform that para makuha yung mass. Kasi 'di ba, ang ating kinetic energy is equal to 1/2 mass times velocity squared. So, para makuha yung mass na yon ng box, kailangan natin gamitin to wherein our mass will be equal to the weight divided by the acceleration due to gravity. So, we will have there 14,000 na naman ako. 1,470 divided by 9.8 meters per second square. This is Newton. So, in here, so, pwede natin compute yan. We'll have here 1,470 divided by 9.8. So, we'll have here 150 kilograms. Bakit siya naging kilogram? Kasi maalala nyo, ang Newton ay kilogram meter per second square. Okay. So, Meron na tayong mass. Okay? So, next na lang natin ay kailangan natin yung values ng ating K1. So, paano natin kukompute yung value ng K1 natin? So, for that, we just need to use this one. So, we'll have here K1 is actually just equal to 1 half times the mass times the velocity of V1 squared. So, we will have here 1 half, mass is 150 kilograms. Okay? Then, we have here velocity squared. Ang velocity squared natin ay, nasa yung V1 natin? V1 is 2.0 meters per second. We just need to square that. Okay? Then, we will have here, this will be equal to our 1 half of 150, that's 75. 75 times 2, 4. 75 times, anyway, so we'll have here 0.5. Let's just multiply that to 150. Then multiply that to 2. That will be 300. Sorry. So that will be zero point 0.5 times 150 times 2 square. Square nga pala yan, ano. So that will be 300. So we will have here, oh, sorry. So we will have here 300 joules. So bakit siya naging joules, sir? Parang ano yan, nagkaroon tayo ng meter squared dito. Okay, then second square. Ang ating Newton ay kilogram meter second square. So magkakaroon ka ng Newton meter. So kaya siya naging uh, naging joules. So pakita lang natin. So we have here 300 kilogram meter square per second square. Kung ihiwalay mo yung isang meter dyan, kakaroon ka ng meter, kilogram, meter, second square. Itong kilogram, meter, second square ay equal sa ating Newton. Tapos meter. Newton meter is joules. Kaya meron tayo dyan 300 joules. Okay? So, ang kailangan na lang natin ngayon ay yung ating K2. So, paano natin i-compute ang ating K2? Pero basically, hindi naman natin kailangan talaga yung K2. Ang kailangan natin yung V2. So, ang K2 natin is equal to our 1 half times the mass, which is 150 kilograms. Then, we have here our V2 squared. Okay? So, sabi natin kanina, gagamitin natin to. Wherein, pwede natin siyang isulat na magkakaroon tayo dito ng K2 natin is equal to our total work plus our K1. Okay? So, that will be actually equal to our ang K2 natin ay yung ating 1,000. Tama, 1,000. 1,000 joules. Ito yung kanina. Plus yung K1 natin, which is 300 joules. Okay? So, we will have here K2 is actually equal to 1,300 joules. Okay? So, that 1,300 joules ay gagamitin natin dito. So, we'll have here 1,300 joules is equal to 1 half of 150. So, let na natin. Sige, 1 half of 150 kilograms. V2 squared. So, isolate lang natin yung V2 squared. So, we'll have here V2 squared is actually equal to 13,000 joules. 1,300 joules divided by, multiply ko na lang to 75 kilograms. Okay? So, kulang ako ng space. Anyway, so kapag nilagay natin yan sa calcu, since gusto natin ay v squared, magkakaroon tayo dyan ng square root, Bali kasi gagawin natin ganyan. So, para makuha natin yung V2. So, ang V2 natin ay magiging kasi yung square root. Square root, not that. Square root of, so we'll have here 1,300 divided by 75. In natin sa loob ng parentheses, kunin natin yung square root. So we'll have here 4 point, we'll have here 4.16 meters per second. So that is how you will calculate your speed using kinetic energy and total work. So first natin ginawa, ina-identify muna natin lahat ng given, then na-identify natin na V2 yung kailangan natin. Mga relevant na equations na kailangan natin gamitin, yung ating work energy theorem. Also, we need our definition of kinetic energy. Kinuha natin, since ang binigay sa atin ay weight, kailangan natin siyang i-convert sa mass. So, bali yung weight, yung 1,470 newtons, dinivide natin sa 9.8 meters per second square, which is actually our acceleration due to gravity. Na-compute natin dyan yung 150 kilogram na mass. And using that 150 kilograms, pwede na natin makuha yung K1, which is K1 is just equal to the 1/2 of the mass, which is 150, multiplied to the square of the initial velocity, which is 2 meters per second. Okay? So, dyan natin nakuha yung ating uh, 300 joules. Then, ginamit natin yung ating work energy theorem, wherein yung K2 natin ay equal dun sa total ng work natin, which is actually 1,000, plus yung K1 natin. So, paano siya naging plus? Imagine yung plus. So, we'll have here yung ating total, K2 minus K1. Minove mo yung K2. So, nagkaroon ka na get negative K2. Minove mo yung ating work. So, nagkaroon ka ng negative work minus. Tapos, minultiply mo lang yung buong equation na yan sa negative, kaya naging positive na. Okay. So, in that, nakuha natin ang K2 is equal to 1,300 joules. Then, sinubstitute natin yung 1,300 joules na yan dito sa K2 na ito. Kaya nakuha natin yung 1,300 joules is equal to 1/2 of 75 kilograms times the square of the P2 or the final speed. So in that, ayan, kinuha natin yung square root nung division or nung ano natin, pag-simplify. And we have there 4.16 meters per second. So that is our calculations of speed using work and energy. And actually, I think this ends the discussion. So here are some summary of what we have discussed today. We have here the definition of force, then by a force. We also have here the SI unit of work. We also discussed that work is a scalar property, which can be positive, negative, but has no direction in space. Also, we have kinetic energy is the amount of work required to accelerate the particle from rest to speed. And also, it is equal to the amount of work particle can do in the process for being brought to rest. So we have here our kinetic energy is just equal to the 1/2 of the mass times the square of the velocity of the particle. We also have here the work energy theorem. And also, wag natin kalimutan, kapag angled yung ating force, our work is equal to our direction of the force times uh, the straight displacement, a straight line displacement times the cosine of the angle, maybe a theta or a phi or kung ano. So, that is our discussion for work and energy. So, expect a quiz next meeting, which is on Tuesday. Okay? Thank you and have a great day. Bye bye.